Let's now have a look at how we go about solving a logarithm with a fractional base that is not aligned with the fractional argument. So remember to switch the terms in the numerator and the denominator, change the sign of the exponent. We reviewed this earlier in the chapter. Here is another situation in which that property comes into play. So let's say we have a log of base a over b, and we raise that to a power of negative y. This negative y is then going to be distributed to both the a in the numerator and the b in the denominator. And now we can switch these terms in order to make the exponents positive. So log of base a over b, when this is raised to a negative power, the argument is a fraction that is a result of switching the original numerator and the denominator. So why is this important? When we are using numerical values, this will lead to an argument that is not aligned with the base, such as this one. So let's say we have log of base 2/3, and we raise that to a power of negative 2. The argument will then be 2/3 raised to a power of negative 2. And when we distribute this negative 2 to the numerator and the denominator, we get 2 to a power of negative 2 over 3 to a power of negative 2. And then if we switch these terms, that will make the exponents positive. And 3 squared will be 9, and 2 squared will be 4. So we see we can have a fractional base, and this will lead to an argument that is also a fraction that is not aligned, and this will happen when the logarithm is negative. So when you have a logarithmic function that is negative with a fractional base, that lets you know that the base and the argument are not aligned. Okay, so let's take this information and now walk through an example from the beginning together. Let's say you were asked to evaluate a log of base 3/4 of 64/27. What is this equal to? So again, when we have a base that is a fraction, step 1 is going to be to set the logarithm equal to y. And step 2 is the same as before. We're going to convert this function to exponential form. So we take our base, 3/4, raise it to a power of y, and set that equal to the argument 64/27. And now step 3, we want to distribute the exponent y to the numerator and the denominator, giving us 3 to a power of y over 4 to a power of y is equal to 64/27. And now we want to check the alignment of the fractions. So you may notice that steps 1 through 4 are the same. So if the base is a fraction, the first 4 steps will remain the same. And it is at this step where things will change, because when we check the alignment of the fractions, we will notice that for the numerators, we have 3 to a power of y is equal to 64. And we cannot multiply 3 times itself and wind up with a product of 64. And if we look at the denominators, we get 4 to a power of y is equal to 27. And we cannot multiply 4 times itself and wind up with a product of 27, letting us know that these fractions are not aligned. So at this step, our 5th step is now to make each exponent negative by switching the terms in the numerator and the denominator. So that will lead to us having 4 to a power of negative y over 3 to a power of negative y. And since we now switch the exponent or the power from positive y to negative y, we want to set the function equal to negative y now. So we have log of base 3/4 of 64/27 is equal to negative y. And now by switching y to negative y, step 7, we can use the numerators or the denominators to solve for y. So if we use the numerators, we have 4 to a power of y is equal to 64. We can ignore the negative for this step. We're trying to figure out how many times we multiply 4 times itself to get to 64. And 4 times 4 would be 16. And 16 times 4 would be 64. So we multiply the base times itself 3 times, which means y is 3. And if we use the denominator instead, 3 times 3 is 9, and 9 times 3 is 27. Again, showing us that y is equal to 3. So if y is equal to 3, then we know log of base 3/4 of 64/27 is equal to negative 3. So that is how we go about evaluating a log with a fractional base that is not aligned with the argument. Let's now have you try a few practice questions. Question number 1. Evaluate a log of base 3/2 of 8/27. Question number 2. A log of base 2/5 of 25/4. And question number 3, a log of base 1/4 of 64. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We're given log of base 3/2 of 8/27. And since our base is a fraction, step 1 is going to be to set the function equal to y. And now step 2, we want to convert the function to exponential form. So we take our base 3/2, raise it to a power of y, and set that equal to the argument 8/27. And now, step 3, we want to distribute the exponent y to the numerator and the denominator, giving us 3 to a power of y over 2 to a power of y is equal to 8/27. And now, once we do that, we can check the alignment of the fractions. And we see that this base 3 cannot be multiplied times itself to get a product of 8. And in the denominator, we have 2 to a power of y is equal to 27, and this does not check out since this base 2 cannot be multiplied times itself to get a product of 27. So this lets us know that we'll need to switch the terms in the numerator and the denominator. So step 5, make each exponent y negative by switching the terms in the numerator and the denominator. So that will give us 2 to a power of negative y over 3 to a power of negative y. And since we switched our y to negative y, we want to set the function equal to negative y instead. And now we can use the numerators or the denominators to solve for y. If we use the numerators, we want to find out how many times we multiply 2 times itself to get 8. And the answer would be 3. So we see that y is equal to 3. Or if you use the denominators instead, we want to find how many times you multiply 3 times itself to get 27. And again, we find that y is equal to 3. So if y is equal to 3, that lets us know that a log of base 3/2 of 8/27 is equal to negative 3. That is the answer to question number 1. Let's now have a look at question number 2. We are given log of base 2/5 of 25/4. And since our base is a fraction, step 1 is going to be to set the function equal to y. And now step 2, we want to convert the function to exponential form, giving us 2/5 raised to a power of y is equal to 25/4. And now step 3, we want to distribute the exponent y to the numerator and the denominator, giving us 2 to a power of y over 5 to a power of y is equal to 25 over 4. And now when we check the alignment of the fractions, we see that this base of 2 cannot get a product of 25. And this base of 5 cannot get a product of 4, letting us know that we'll need to switch the terms in the numerator and the denominator over here. This will make each exponent y negative. And if we're making these y's negative, we need to make this y negative as well. And now we can use the numerators or the denominators to solve for y. So if you chose to use the numerators, we want to find how many times we multiply 5 times itself to get a product of 25. And the answer would be 2. So we find that y is equal to 2. Or if you use the denominators instead, you want to find how many times you multiply 2 times itself to get a product of 4. And the answer is 2. So in both scenarios, we find that y is 2, which lets us know that a log of base 2/5 of 25/4 is equal to negative 2. So that is the answer to question number 2. Let's now have a look at question number 3. We want to evaluate the log of a base of 1/4 of 64. Step 1, we want to set the function equal to y. And now step 2, we want to convert the function to exponential form, which will give us 1/4 raised to a power of y is equal to 64. And 64 is equivalent to 64 over 1. So now we have fractions on both sides. And now step 3, we want to distribute the exponent y to the numerator and the denominator, giving us 1 to a power of y over 4 to a power of y is equal to 64 over 1. And now we can check the alignment of the fractions. We cannot multiply 1 times itself and wind up with a product of 64, so that does not work. And we cannot multiply 4 times itself and wind up with a product of 1, so that does not work. So this lets us know that we'll need to switch these terms over here. So step 5, make each exponent y negative by switching the terms in the numerator and the denominator, giving us 4 to negative y over 1 to the negative y. And since we switch these y's to negative y, step 6 is we want to set the function equal to negative y instead of y. And once we do so, we see that our denominators will not help us solve for y, since our base is 1 and the product would be 1. So we'll focus on using the numerators to solve for y. So how many times do we multiply the base 4 times itself to get 64? The answer would be 3 times. 4 times 4 is 16, and 16 times 4 is 64. So if y is 3, that lets us know the answer is negative 3. So log of 1/4 of 64 is equal to negative 3.